What is a model spec? A model spec is a declarative specification for deploying AI models. It describes what a model is, what it needs, and how it should behave in production, without prescribing exactly how it must be deployed. The goal of model spec is to make model deployment simpler, more predictable, and easier to automate. Today, deploying a model usually means stitching together many different pieces: configuration files, runtime flags, infrastructure assumptions, and undocumented conventions. As systems grow, these pieces become tightly coupled and fragile. Small changes can lead to unexpected behavior, performance regressions, or outages, often without a clear understanding of why. One of the biggest problems in production AI systems is the gap between intent and reality. Intent is what you think you deployed, the resources you expected, the latency you aimed for, the behavior you designed. Reality is what actually runs in production, influenced by defaults, constraints, and hidden assumptions. Model spec is designed to narrow that gap. Model spec focuses on intent, not mechanics. Instead of describing step-by-step deployment instructions, it captures the essential requirements and expectations of a model. This includes things like resource needs, performance goals, and operational constraints, independent of any specific platform or runtime. A model spec typically includes 4 categories of information. First, model identity: what the model is, its version, and its purpose. Second, resource requirements, such as GPU needs, memory, and precision. Third, serving intent, including latency targets, throughput expectations, and concurrency. And finally, operational constraints, like isolation, observability, and compliance considerations. Model spec is not a replacement for existing infrastructure tools. It's not Kubernetes YAML. It's not Terraform. It's not a runtime configuration file. Instead, model spec acts as input to those systems, providing a higher-level description that can be validated, analyzed, and compiled into concrete deployment artifacts. Here's a simplified example of what a model spec might look like. This specification says, I want to serve this model for this task with these resource requirements and these performance goals. Notice what's missing. There are no platform-specific details, no cloud provider settings, and no runtime flags. That separation is intentional. In practice, a model spec flows through a pipeline. The specification is validated and compiled into an intermediate representation. Back-end plugins then translate that representation into platform-specific artifacts, such as Kubernetes manifests or runtime configuration. This allows the same intent to be reused across environments. When intent is explicit and machine-readable, automation becomes possible. Model specs enable validation before deployment, detection of mismatches, and consistent behavior across environments. Over time, this creates a foundation for optimization, cost control, and compliance, without increasing operational complexity. Model spec is an open, evolving specification. You can explore the schema, examples, and documentation in the GitHub repository linked below. Whether you're an ML engineer, a platform engineer, or operating models in production, model spec is designed to give you a clearer, more reliable way to express model intent. Model spec is just the starting point. In the next videos, we'll walk through real deployment examples, from single GPU inference to multi-tenant clusters, and show how intent, facts, and rules come together to make AI systems predictable, governable, and cost-efficient. Stay tuned.